Let's talk about the law of definite proportions. This law was created by Joseph Louis Proust in 1799, and it states that compounds always contain elements in certain definite proportions and in no other combinations. So what does this really mean? So for example, carbon monoxide will always have carbon and oxygen in the same mass ratio. So here's carbon and here's oxygen. So that is, one atom of carbon has an atomic mass of 12, and one atom of oxygen has an atomic mass of 16. But to further reduce this ratio, you divide by 4 on both sides. So 12 divided by 4 is equal to 3, and 16 divided by 4 is equal to 4. So it's a 3 to 4 mass ratio. So these are the definite proportions, and there can be no other combinations. Carbon monoxide will always be one atom of carbon and one atom of oxygen. So let's move on to another example. Let's talk about H2O. So H2O will always have a mass ratio of 1 to 8. And how do you determine this ratio? Well, it's determined from the following calculation. That is, 2 atoms of hydrogen, you take those and you multiply them by the atomic mass of hydrogen, which is 1, and that is equal to 2. And 1 atom of oxygen has an atomic mass of 16. So let me move this over here because we can further reduce this ratio. You divide by 2 on both sides. So 2 divided by 2 is 1, and 16 divided by 2 is 8. So there's a 1 to 8 mass ratio. So those are the certain definite proportions, and there can be no other combinations. H2O will always be 2 atoms of hydrogen and 1 atom of oxygen. So now let's work out some problems. So I've already stated this law, so we don't need to go over that anymore. But I'm going to work out these problems for you so you can understand this law better. So the first problem is, carbon combines with oxygen in a ratio of 3 parts by mass of carbon to 4 parts by mass of oxygen to form a poisonous gas called carbon monoxide, or a capital C, capital O. So how much oxygen is needed to combine with 300 grams of carbon to form carbon monoxide? Well, let's really look at this. Let's take the 300 grams of carbon, and I'll work out the rest of the problem to the side over there, because I know I'm going to run out of room here. So we're going to take the 300 grams of carbon, and we're going to multiply those by, well, now visualize this part in the numerator, because that's where it's at, the 300 grams of carbon. And you need to come up with oxygen, so you know you need to get rid of the grams of carbon. So that being said, there are 3 parts by mass of carbon. So let's put the 3 grams of carbon on the bottom. And on the top, you're going to put the 4 parts by mass of oxygen. So let's put 4 grams of oxygen. That's what that means. So that being said, these are going to cancel out. And that's going to leave you with 300 times 4, which is 1,200 grams of oxygen divided by 3, which is equal to 400 grams of oxygen. So that's your final answer. You need 400 grams of oxygen to combine with 300 grams of carbon to form carbon monoxide. So let's move on to the next problem. I'm going to erase this, but as usual, you can go back in the video and capture that, how we did that problem. So that being said, let's move on to the next problem. Water, or H2O, via electrolysis can be decomposed to give 1 part by mass of hydrogen and 8 parts by mass of oxygen. What mass of hydrogen is obtained if water is decomposed to give 0.8881 grams of oxygen? Well, let's work out this problem here. Now I'm going to work off to the side as well if I can't fit all of this in here. So you're going to take the 0.88, whoa, look at my 8s there. So let's start all over. So 0.8881 grams of oxygen. And you're going to multiply that, all right? Now, the problem is saying you have 1 part by mass of hydrogen and 8 parts by mass of oxygen. Now, the 0.8881 grams of oxygen is in the numerator. So in order to cancel out the grams of oxygen, because you need to determine the mass of hydrogen, because that's what you need to come up with, hydrogen, you're going to put the 8 grams of oxygen on the bottom. And on the top, you're going to put the 1 gram of hydrogen. So now what's going to happen here is you're going to cancel these out, and you're going to have 0.8881 grams of hydrogen divided by 8. So you take your calculator and you're going to find out what that answer is, which I've already calculated. And it's going to be 0.111 grams of hydrogen. And, well, let me write that H again. So that's your final answer. And that's your law of definite proportions.